Today we're going to look at section P.3, and that involves us looking more at radicals and rational exponents. So today our objective is to understand and use rational exponents. So remember, rational exponents we define as rational exponents so that their properties are the same as the properties for integer exponents. So anytime we're thinking rational, in this case, we're thinking fractions. So we're really thinking about fractions as exponents. So notice that if I have 7 to the 1/2 power, but that's being squared, when you have two exponents, a power to a power, that means you multiply them together. Notice that in this case, 1/2 and 2, those are reciprocals of each other. So it turned into 1, and so that gets us 7. Well, notice that if I was to take the square root of 7, quantity squared, well, if I'm squaring a square root, I'm multiplying it by itself 2 times. And so anytime I multiply radicals together, I get to multiply the numbers together and keep it underneath one big radical. So 7 times 7 is 49, and then the square root of 49 is 7. So notice that my exponent being a fraction and my radical ended up getting me the same answer. And that's not a coincidence. That's going to be our definition. So therefore, in this case, 7 to the 1/2 power is equivalent or equal to the square root of 7. So here's our formal definition. So it's the definition of a to the m over n power. So if we have the nth root of a represents a as a real number and m over n as a positive rational number, n has to be greater than or equal to 2 because remember the smallest radical that we can have is a square root. And so that means that our index is technically a 2. So then it says that a to the m over n power equals the nth root of a quantity to the mth power. Or if we have a negative exponent, don't forget that then we want to move exponents where they only become positive. So in this case, it would move down to the denominator. And so 1 over a to the m over n power is the same thing as a to the negative m over nth power. Okay, so let's look at some practice problems. So it's asking us to simplify negative 81 to the 1/4 power. So here's the thing, because there is no parentheses around the negative and the number, that means that the negative is going to stay on the outside. It has nothing to do with the 81. And in this case, because 1/4 is my exponent, the denominator of 4 becomes the index. So I get to have the 4th roots, and then 81 is going to be the number that's underneath. Technically, that is being raised to the 1st power because whatever the numerator is what you're raising it to. But in this case, because it is a 1, we don't really have to write it. Okay, so that tells us that my final answer is going to be negative, but now I want the 4th root of 81. So remember that index tells us that we should have 4 of the same number. So hopefully we're okay with the fact that 81 is 9 times 9, but 9 is broken up into 3 and 3. So really, multiply 3 by itself 4 times, that gets us 81. But because I have that negative, that means that negative 3 is going to be my answer. In this next one, because there are parentheses around the negative and the 8, that means that the negative is going to stick with the 8. So notice that my index is 3. And so because we are dealing with an odd index, that's what makes it okay to have a negative underneath that radical. Once again, I could technically raise that to the 1st power, but that's not going to change anything, so I don't have to. So then in this case, because I have an index of 3, I'm looking for 3 of the same number. Because the number underneath is negative, that means that these numbers are going to have to all be negative. And so notice that if I multiplied negative 2 by itself 3 times, that's going to get me negative 8. So that's why my final answer is negative 2. If I want to simplify 8 to the 5/3 power, notice this time we have something in the numerator that is not a 1, so we are going to have to make sure that we know how to write this. So I'm going to rewrite it as a radical. 3 is my index, 8 goes underneath, and then this is raised to the 5th power. So kind of similar to that last example, I know that since 3 is my index, I'm looking for 3 of the same number. Since 8 is positive, I know that these numbers are going to be positive. So the cubed root of 8, we do what's in parentheses first, that is the number 2. But then I still have that exponent on the outside. So now I have 2 to the 5th power. So if I multiply 2 by itself 5 times, that's going to get us 32. So 32 is my answer. In the next one, notice that I'm dealing with a negative exponent. So before I do anything else, I want to get rid of the negative exponent. So I have to make it a fraction. So it's really 1 over 16 to the 3/2 power. And now that I've changed that to a positive exponent, now I can focus on, okay, it's the denominator that I'm going to rewrite. So since technically my index is 2, you can write a 2 if you want, but remember that's the same thing as just that square root. So I don't really need that index of 2. If you write it, it's not going to hurt anything, but you don't really have to. But then remember, since there's a number in the numerator, I have to raise it to that power, so it's getting raised to the 3rd power. So now in this case, I start with what's in parentheses. The square root of 16 is going to be 4. And so now I want to cube 4, but that's in my denominator. So I have a fraction still, so it's 1 over. Well, 4 times 4 times 4 is going to be 64. So 1 over 64 is going to be my answer. So I would suggest that you pause the video, try these 2 checkpoint problems. Okay, notice that in the first one, it's the cubed root of 1,000, which means what's the same number being multiplied by itself 3 times, and so that answer is 10. Notice how in the second problem here, I had to change this into a fraction in order to get rid of that negative exponent. I rewrote it as the square root of 64 to the 3rd power in the denominator. Square root of 64 is 8. 8 cubed give us 512. Once again, though, that's in the bottom of our fraction. All right, so that's us understanding and using rational exponents.